You know, we rarely think about the plumbing behind our pixels. You buy a new 4K TV, you grab whatever HDMI cable is in a drawer, and you plug it in. But there's a breaking point, right?
Right.
What happens when that 4K signal has to travel, I don't know, across a huge room or through the walls of a hospital?
That's exactly it. That's where you hit what engineers call the cliff effect. Standard copper cables, they're fine for short hops, a few feet. But once you start pushing that much data past, say, 15 feet, the signal just degrades instantly. You get those sparkles or, dropouts or just a black screen. Nothing.
Which brings us right to the hardware for today's deep dive. It's the NTI HD4K18GB-FO-25M-MM. That is a mouthful of a name. But what it is a 25-meter HDMI cable that's about 82 feet. It costs $210.
Right, and that price tag is a huge clue. This isn't really a cable in the way we usually think of one. It's an active piece of tech, the FO in the name, that stands for fiber optic. We're not just pushing electricity down a long wire. We're converting those electrons into photons, into light.
Okay, let's get into the construction, because the spec sheet calls it hybrid. So it's not pure glass fiber. It says here there are also 7 copper conductors inside. Why mix them?
It's a really strategic balance. The fiber optic cores, they handle the important stuff, the high-speed video data. And light, you see, is immune to electromagnetic interference. So all that noise from power lines or heavy machinery that would just ruin a copper signal, it doesn't touch the fiber.
So the fiber is doing the heavy lifting, the full 18 gigabits per second for that 4K signal.
Exactly. And that 18 gig bandwidth is absolutely critical. It supports full Ultra HD 4K at 60 hertz with 4.4.4 color sampling.
And for anyone listening who isn't a video engineer, 4.4.4, that basically means no compression, correct?
You got it. Most video you stream, it throws away some color data to save space. That's 4.2.0. This cable delivers the raw, uncompressed signal. Every single pixel gets its own unique color information. That's why they say the image is crystal clear.
And even with all this tech inside, it's surprisingly practical. The specs say it's only 4.5 millimeters thick. And it has a bend radius of 48 millimeters. That's pretty flexible.
Well, that's another huge benefit of fiber over copper. If you try to send 4K over 80 feet with a copper cable, it would have to be thick as a garden hose and really heavy just to shield the signal. This is light, it's flexible, you can actually snake it through a wall.
Now, I know with active cables, there's usually a catch. You're halfway through installing it and you realize you need to find a wall outlet for a little USB power booster.
Yeah, that's the installer's nightmare. But NTI engineered a really clever workaround here. This cable requires absolutely no external power supply.
Wait, so it's self-powering. How does that work?
It literally siphons power from the HDMI port itself, from pin 18 specifically. So as long as your source device, your PC or Blu-ray player, can output at least 500 milliamps, it powers the lasers inside the cable automatically.
That is elegant. So the copper wires we mentioned, they're not just dead weight then. They must handle the handshakes.
Yes, exactly. Things like EDIDE and HDCP. EDIDE is how the display tells the source, hey, I'm a 4K screen, send me a 4K signal. And HDCP is the copyright protection. The copper handles that two-way chatter, while the fiber just blasts the video one way. It also supports high-end audio formats, Dolby True HD, ARC, all that.
Okay, so let's circle back to that $210 price. Who is this actually for? Because if I'm just hooking up a game console in my living room, this is serious overkill.
Oh, definitely. This is for situations where failure is not an option. The spec sheet lists medical imaging, for instance. If a surgeon is looking at a 4K display during a procedure, they cannot have the screen flicker because some other machine turned on.
That noise immunity thing again.
Precisely. Or think about airplanes. Every single ounce on a plane matters. Running lightweight fiber instead of heavy shielded copper for the onboard video, it actually saves fuel. And digital signage, of course. The computer is in a back office, but the menu board is 80 feet away at the front counter. You need that reach. And we're just looking at the 25-meter version. This tech can go up to 100 meters.
So it's really an insurance policy. You're paying to guarantee the signal arrives perfectly intact, no matter the distance or the environment.
That's a great way to put it. It's a fundamental shift, moving from just passive wires to active data pipelines.
It really is.
And it leaves us with, I think, a pretty interesting question for you to consider. As we push past 4K to 8K and video bandwidth demands double, then quadruple, have we finally reached the end of the copper age for this stuff? Are we looking at a future where all the wires in our walls and even our homes have to run on light just to keep up?